Hi, this is Mrs McTaggart. In this video we're going to just have a little look at some different properties of straight lines. We're going to look at what it means for lines to be perpendicular, and we're just going to remind ourselves of a wee bit of vertical and horizontal lines from National 5 because they do crop up sometimes in higher, and it's really good to remember basic equations of lines that are vertical or horizontal. So we'll talk about that first. So here is a little reminder of horizontal and vertical lines. My red line is a line that has a gradient of 0, and that's really easy to understand because if the ground is flat there's no slope, so gradient of 0, yeah? Now every single point on this line is along something different, but they all have the exact same y coordinate. Would you agree? Of course, right? So this red line I've drawn might all have a y coordinate of 3. So it's safe to say that whatever number it goes through in the y-axis, I've called A here, is what y equals on that line. So if I told you that they all went through 3, you would say, oh, this line is the line y equals 3. Similarly, if I put another one up in here and I said it went through 7, you'd be like, oh, well, that's the line y equals 7. Okay? Can we remember that? Hopefully. Now, the other line I've got drawn is my blue line here. Now, my blue line, every single point on that line has an identical x coordinate, yeah? So it's safe to say in this scenario, x is always the same. So if I told you this line was 4 along, this would be the line x equals 4. Yeah? And if I do another one over here and told you that this went through the x coordinate of 10, that would be the line x equals 10. So think about it as being, oh, the x is always the same, so x equals that number. Or the y is always the same, so the y equals that number. Now let's chat about the gradients of these lines. I mentioned that the red line has a gradient of 0. That blue line is said to be perpendicular to the red line. It's done a complete 90-degree turn. The angle between them is 90 degrees. So perpendicular is a fancy word for meeting at right angles. And that might have been mentioned at National 5. It might not have. Now if two lines are perpendicular, they meet at right angles. I've already mentioned that. These two, I didn't mention this blue line. This is a very special line. Its gradient is undefined. So if it's perfectly vertical, like that blue line, you can't say the gradient is 0. It's undefined. So that whole bit doesn't really exist. So that's why these two kind of lines have very special equations, y equals and x equals. So let's look at example 1. It's asking us to find the equation of the line parallel to the y-axis through 3, 1. So we're looking for an equation of a line. So we need 3 things. Remember, we need our point, we need a gradient, and then we need an equation. Now, we already know the point is 3, 1. Our gradient, now if it's parallel to the y-axis, a little picture helps you here. Parallel to the y-axis means it's this line here, and that is an undefined line. And if it's going through the coordinate 3, 1, then that means in this instance, my x coordinate is always 3. So the equation is just x equals 3. This has got an undefined gradient, so we can't actually do a gradient for it. So it's one of our special lines, okay? So parallel to the y-axis, draw a little picture. Similarly, if they'd changed that and said parallel to the x-axis, you would have said, okay, parallel to the x-axis means it's a line going like this. So it's going through 3, 1. Oh, it's horizontal, so the gradient would be 0. And you would just go do the equation of the line, plug in the coordinates and do y minus 1 equals 0 for the gradient, x minus 3. In actual sense, this all just gives you nothing on the right-hand side. So you've got the equation y equals 1. All right, so that was if we wanted the one parallel to the x-axis instead of the y-axis. So any mention of parallel, x-axis, y-axis, draw a little sketch. It helps illustrate what's going on. It helps you remember horizontal gradient 0, vertical undefined gradient. So it's either going to be x equals or y equals. Example 2, find the equation of a line perpendicular to the line x equals 5 through 7, 2. So I'm going to draw a little picture again. So here is my x and y axis. The line x equals 5 has an x coordinate of always 5. I want the line parallel to that one. Sorry, perpendicular, get your words right. Perpendicular to this one. So perpendicular means it's at right angles like this, and it's going through the point 7, -2. So this line that I'm trying to find here is this one. It is horizontal, so my gradient is 0. My point is 7, -2. And in fact, every single point on this line has a y coordinate of -2. So my line is just going to be y equals -2. But you can still go to your line formula and plug in, and it will give you that answer out naturally. So we'll do y plus 2 equals a gradient of 0, bracket x minus 7. So that whole right-hand side becomes 0. Take the 2 over, you get y equals -2. You don't have to go straight to the answer if you're not too sure and just want to double check. You can always just plug in as normal your gradient of 0 and your coordinate. Now let's talk about perpendicular lines in a different sense. My examples so far have been talking about horizontal and vertical and being perpendicular to that. But what if I had a sloped line and I wanted perpendicular to it? So it still means that perpendicular means it goes. This is a new bit down here, this formula here. If they are perpendicular, the product, fancy word for multiplication, of their gradients will always give you -1. And if I was in class, I'd get the decimal graphics calculator out and I'd try and show you some perpendicular lines. However, it's pretty hard to do on the video, so I've done my best to try and show you a couple of lines that are easy to explain. So what we've got here is, if we look at just my red line just now, my red line has a gradient, has got the equation y equals 2/3 x. Now back when you're taught gradient, 2/3 stands for your vertical over horizontal. So look, I've got 2 boxes vertical, 3 horizontal to that, yeah? Now I've then drawn on my blue line. My blue line has the equation y equals -3/2x. And it is at right angles. You can clearly see that from the diagram. It's at right angles to that one. But notice this time when I'm doing my vertical over horizontal, my vertical is 3 boxes, my horizontal is 2. So there's my vertical and horizontal. Now you might see the connection between this 2/3 and the -3/2, but when you multiply them together, you will get -6/6, which is just -1. Or you can say the 3 and the 3 cancel, the 2 and the 2 cancel, and you're just left with -1. So these two lines I'm just trying to show you visually are perpendicular. One is a gradient 2/3, which you can see from the 2 vertical, 3 horizontal. One has a gradient of -3/2, it's sloping down the way. 3/2, they are perpendicular, and when I multiply them together, I get the gradient -1. So it's just proving that little formula again. Gradient 1 times gradient 2 equals -1. Now you might also notice a little something else in common here. The first gradient and the second gradient, if you have a look at those if I take all this away, if you have a look at them, what do you notice about it? What have I done? I have literally flipped the first fraction and introduced a negative. This is a little trick that's going to become apparent when you're doing this, and that's what most pupils then go on and do. This whole gradient 1, gradient 2 multiplied given -1 is more a statement you write if you're asked to prove something is perpendicular. So let's just go look at some examples of working out some perpendicular gradients. A few on this next screen. Now the notation for this is I write it, for a perpendicular gradient, I write it M with a little perpendicular sign like that underneath. I know when I did it at school, or other teachers will write it as M perp. Your teacher might have a slightly different notation, but I do M with a little perpendicular sign at it. So a gradient of 6, make that perpendicular. Now remember, that is really 6/1. If you were to flip that, that would give you 1/6. But my first gradient was positive, my second gradient will be negative. And if you were to then go multiply these, remember 6/1 times -1/6 will give you -1. Okay, so here is my perpendicular gradient. Essentially what I've done is I've thought it was a 6/1, I've flipped it and I've changed the sign. Right, gradient of -4, so my perpendicular gradient, remember that is just -4/1. Flip it, change the sign, would give you 1/4. And when you multiply them together, you'll get -1. Let's look at ones where it's fractions instead. So the perpendicular gradient to a half, flip it and change the sign, would give you -2/1. But remember, we don't ever need over 1 in math, so we'll just take that straight back out. So it's just a gradient of -2 for that one. And then for my last one, gradient perpendicular to -3/4, flip it, would give you 4/3. Change the sign from negative to positive. There is your gradient. Okay, and then obviously as a quick check, when you multiply them back together, you'll always get -1 as your answer. Let's example 4. So this is asking you to find the equation of a line through the point 2, 4, perpendicular to this line here. Now, perpendicular, we know, means meet at right angles. This line here is in the wrong format, so the first thing we're going to do is rearrange this. So this is the same as 4y equals, take the 2 over, it will give you -2x. Oops, a daisy. Take the 10 over, will give you +10. Divide these both by 4, will give you -2/4. In fact, that's just going to be a half, yeah? So we'll just write that as -1/2 x plus 10/4 or 5/2. That's really quite irrelevant anyway. It's this we're looking at. So our current gradient is -1/2. The perpendicular gradient to that would be flipping it and changing the sign. So it would be positive. It would be 2/1, but we don't need the over 1, so it would just be 2. And then I've got the point -2, 4. These are what we're going to plug in. We're going to use these numbers plugged in to get the equation of the line. So we've got y -4 equals our gradient -1/2 bracket x plus 2. Multiply at the right hand side. 2y -8 equals -x -2. 2y equals -x. Add on 8 to that gives you +6. You can half this if you want, or you can leave it as 2y equals. It's up to you, but it does come back to -1/2 x plus 3 if you wanted to. Okay, so that's quite often a question I'll ask you. Maybe it asks for a parallel to that one, maybe it asks for perpendicular, but it's all about going, right, perpendicular, get me the gradient in that line, find the perpendicular one, get the equation of a line as normal. One last example here is to prove that these two lines are perpendicular. So this is where this little m1 times m2 equals -1 is important. So first thing is we're going to rearrange both of these equations. Let's start with this first one. So that will give us 3y equals x will move over and become negative. The 6 will become negative. We need to divide by 3. So I've got -1/3 x take away 2 for our first line. Our second line is already there. Y equals 3x take away 1. So the gradient of our first line is -1/3. The gradient of our second line is 3. A quick check, -1/3 times 3. Put it over 1 if you need to. If you multiply those, you will get -3/3. Oops, it's easy, which is just -1. Now the bit is the proof, right? So we have to write since. I'm just going to steal this from up here actually, this wee bit of writing. So I'm going to write since gradient 1 times gradient 2 equals -1. The lines are perpendicular. Save me writing that out again. Perpendicular. And that is a little proof statement that you have to write. I thought that was in highlighter there. So that is a little proof statement you have to write at the end. We're looking to see that little formula there. It's not just enough to say, oh, they're perpendicular because they're flipped and changed sign. You can't get away with that. You have to write gradient 1 times gradient 2 is -1. All right. Similarly, if you were to prove that they weren't perpendicular, you would say that gradient 1 times gradient 2 does not equal -1. Okay. This has been quite a long video. I appreciate there's quite a lot in it. This little perpendicular skill will be needed to find the equation of a perpendicular bisector. Thanks for watching. Bye-bye.